Let's step away from nightmares for a moment and look at planets that don't want to kill you instantly, worlds that might actually welcome life. Not friendly, not easy, but possible. These are the most promising habitable planets ever discovered. And we're starting with one of the most famous star systems in the galaxy. TRAPPIST-1e sits about 40 light-years away, orbiting an ultra-cool red dwarf star. The planet is almost the same size as Earth and lies directly inside the habitable zone, where temperatures allow liquid water to exist. But there's a catch. The planet is tidally locked. One side faces its star forever, trapped in eternal daylight, while the other side is frozen in endless night. But between those two extremes lies the Twilight Zone, a permanent sunset world where temperatures could remain stable. Scientists believe liquid water may exist on the surface, and the atmosphere could circulate heat from the day side to the night side, preventing the planet from freezing solid. Even more promising, TRAPPIST-1e receives about the same amount of radiation from its star as Earth does from the sun. Its density suggests a rocky composition with a large iron core, which increases the chances of a protective magnetic field. The star itself is long-lived. Red dwarfs burn for trillions of years, giving life far more time to evolve than Earth ever had. The danger comes from stellar flares. Red dwarfs are known for violent radiation bursts, but if this planet has a strong magnetic shield, it could survive them. Now let's jump much farther out. Kepler 452b orbits a star remarkably similar to our Sun, located about 1,400 light-years away. The star is only slightly larger and brighter than ours, and the planet itself is a super-Earth, around 60% larger than Earth. It completes one orbit in 385 days, almost identical to our year. But here's what makes it terrifyingly exciting. This planet has existed inside the habitable zone for roughly 6 billion years. That's over 1 billion years longer than Earth. If life follows similar evolutionary timelines, anything living there could be far more advanced. Gravity would be stronger. You'd weigh nearly twice as much. But that extra gravity could help maintain a thick atmosphere, offering better protection from radiation and stabilizing surface temperatures. The biggest unknown is water, but its long-term position in the habitable zone suggests oceans could have formed and persisted for billions of years. Plate tectonics may even be active, recycling nutrients and keeping the climate stable. Now let's move closer, much closer. Proxima Centauri b is the closest known exoplanet to Earth, just 4.2 light-years away. It orbits Proxima Centauri, our nearest stellar neighbor. The planet is slightly larger than Earth and sits inside the habitable zone, but its year lasts only 11 days because it orbits very close to its star. Despite that, Proxima Centauri is much cooler and dimmer than the Sun, meaning the planet receives roughly the same energy Earth does. Like many red dwarf planets, it's likely tidally locked. One side could host liquid oceans under constant daylight, while the other remains frozen. Between them lies another twilight belt, where life might thrive. Recent studies suggest the planet may have an atmosphere, and if it does, powerful winds could distribute heat around the planet. The biggest threat is radiation. Proxima Centauri is extremely active, unleashing massive stellar flares. But again, a strong magnetic field could be the difference between a dead rock and a living world. Because of its proximity, this planet is one of the first targets for future interstellar probes. We may know if life exists there within our lifetimes. Next comes a historic milestone. Kepler 186f was the first Earth-sized planet ever discovered in the habitable zone of another star. It orbits a red dwarf about 500 light-years away and is roughly 10% larger than Earth. Its year lasts 130 days. The star emits most of its energy in infrared light, meaning photosynthesis, if it exists, would be very different. Plants might appear dark, even black, optimized to absorb infrared radiation. The planet lies near the outer edge of the habitable zone, making it cooler than Earth, but a thick greenhouse atmosphere could trap heat and keep water liquid. The star is around 4 billion years old, similar to our Sun, giving life enough time to evolve. Unlike many red dwarfs, this star appears relatively stable. If the planet has a magnetic field and a dense atmosphere, it could support complex life. Now let's talk about gravity. LHS 1140b is a super-Earth orbiting a red dwarf about 40 light-years away. It's around 1.7 times Earth's size and nearly 6 times more massive. That means crushing gravity. You'd weigh about 3 times as much. But that same gravity helps the planet hold onto a thick atmosphere. It orbits comfortably within the habitable zone with a 25-day year. Recent observations suggest the planet might be covered by a global ocean, potentially hundreds of kilometers deep. If true, it would be a water world with no continents. Life there, if it exists, might be entirely aquatic. The star is older than the Sun and unusually calm for a red dwarf, producing fewer flares. That stability makes this planet one of the strongest candidates for life we've ever found. Now let's move to orange dwarfs, the underrated heroes of habitability. Kepler 442 b orbits an orange dwarf star about 1,200 light-years away. The planet is about 30% larger than Earth and completes an orbit in 112 days. Orange dwarfs are smaller and cooler than the Sun, but far more stable than red dwarfs, making them ideal for long-term habitability. Kepler 442b receives about 70% of the light Earth gets, meaning it's slightly cooler, but a thicker atmosphere could easily compensate. Its size suggests a rocky composition with possible plate tectonics. Scientists estimate it has a 97% chance of being in the habitable zone, higher than almost any other known exoplanet. If life exists anywhere beyond Earth, this planet is near the top of the list. Now let's look at a colder world. Kepler 62f orbits a star slightly cooler than the Sun, also about 1,200 light-years away. The planet is around 40% larger than Earth and sits at the outer edge of the habitable zone. It receives less sunlight, comparable to Mars, but a thick, carbon dioxide-rich atmosphere could create a strong greenhouse effect. Scientists believe it may be a global ocean planet with no land at all, and oceans potentially hundreds of kilometers deep. The star is about 7 billion years old, giving life billions of extra years to evolve. If life emerged there early, it could be incredibly advanced. Now imagine a sky with multiple suns. Gliese 667 cc orbits a red dwarf in a triple star system just 24 light-years away. The planet is a super-Earth, with nearly 4 times Earth's mass, and completes an orbit in just 28 days. Depending on the time of year, you could see up to 3 suns in the sky. The planet receives about 90% of Earth's sunlight, but the light is redder. Photosynthetic life would need to adapt. Gravity would be roughly twice Earth's, and the atmosphere would be denser. Tidal locking is a concern, but atmospheric circulation could redistribute heat, making parts of the planet habitable. We return now to the TRAPPIST system. TRAPPIST-1G lies just outside the traditional habitable zone. It receives less light than Earth, similar to Mars, but tidal forces from nearby planets could generate internal heat. That heat might keep a subsurface ocean liquid beneath a thick ice shell. The ice would protect the ocean from radiation, creating a hidden environment where life could exist without sunlight, similar to Europa or Enceladus. And finally, Kepler 1229b orbits a quiet red dwarf about 769 light-years away. The planet is around 1.4 times Earth's size and sits comfortably in the habitable zone with an 87-day orbit. Gravity would be stronger, but that helps retain atmosphere. The star produces fewer flares than most red dwarfs, increasing the chances of long-term stability. Oceans may exist, and where water persists, life tends to follow. These planets aren't Earth, but they don't need to be. They just need time, water, and a little protection from their stars. And somewhere out there, under alien skies, life may already be looking back,